Hello, my amazing math students. This is Mrs. A, and I love math. Tonight, we're doing Lesson 88 in our Saxon Orange Book, and we're talking about quadratic equations and solution of quadratic equations by factoring. Now we're really getting into the fun stuff. So, what are quadratic equations? Well, they are second-degree polynomials. By second degree, we mean that the highest degree term, which means that the power on the variable, is 2. And so the highest degree term is an x squared, or it could be a y squared, but we're going to talk about x squareds right now as the highest degree term. So this right here, 4 minus 3x equals 2x squared, is a quadratic equation because the highest degree on any variable is 2, and that is a quadratic equation, but it is not in standard form. However, this one is in standard form. 3x squared minus 2x plus 4 equals 0. We have everything on the left with just the 0 on the right. And another qualification is it's in descending order of the variable. So 3x squared is the highest term. The next highest term is negative 2x, because that's x to the 1 power. And then plus 4, because a constant is x to the 0 power. So if we have it in descending order of the variable, we go 2, 1, 0 on the powers. So standard form means that all non-zero terms are on the left and the terms are in descending order of the variable. So that is what it means to be quadratic. Now, another special thing is, since a quadratic means that it is a power 2 equation, the highest degree is a power of 2, that means this coefficient that is in front of our x squared term can never be 0. But the other terms could be 0. So 4x squared equals 0 has an x squared term, but it's missing an x term and it's missing a constant term. No worries, it's still a quadratic equation. 4x squared plus 2x is equal to 0 is missing a constant term, but it has an x squared term, therefore it is a quadratic. And this one is missing its x term. 4x squared, there's no x, minus 3 equals 0. But that's okay, because it still has a quadratic term, therefore it is a quadratic equation. Now, learning more about quadratic equations. This is the form of our general equation for quadratic equations. This is the standard form. And we let A be the coefficient for the x squared term. We let B be the coefficient of the x term. And we let C be the constant, which is the coefficient of the x to the 0 term. But right now we can just call it the constant. Now, A, B, and C, these are known everywhere. So if I say, what is the A in a quadratic equation, you would say it is the coefficient of the x squared term. Everybody knows that. Okay, so now what if I tell you that I'm thinking of an equation whose A is 1 and whose B is negative 3 and whose C is negative 10? Well then, if you know anything about quadratic equations, you will say, I know the equation that you're thinking about. You're thinking about A being 1 is the coefficient of the x squared term, and B being negative 3 means that negative 3 is followed by an x, and C is a negative 10. That means my constant is negative 10, and then I have an equal 0 on the other side. This is kind of like a code, isn't it? If I say A is this and B is that and C is that, then you can write the whole equation. Now, remember that we don't need a 1 here, because if we just erase that 1 and we just had x squared, then it is understood that it has a coefficient of 1. Now, when we're looking at an equation, there are a lot of little cool signs and codes in math. A second degree equation has two solutions. It tells you how many solutions it has on its highest degree term. Well, guess what? If I had an x cubed equation and its highest degree term was x cubed, then I could expect to have 3 solutions to that equation. And if I had an x to the 4 at the very beginning of my equation and it was the highest degree term, then I could expect to have 4 solutions. Isn't that cool? Okay, so here we know we have 2 solutions, which means I have 2 numbers that will make this statement true. Lucky for us, the book tells me what they are, but later on in this lesson, we're going to figure out what those solutions are. So the book tells me to check for a 2 and a 5, I believe. Let me look. It says what happens when we plug in a 5 and a negative 2. So we're going to try a 5 and a negative 2 and see if these 2 numbers are the 2 special numbers that makes this a true statement. So if we plug in a 5, then we're going to have 25 minus 3 times 5, which would be minus 15. So 25 minus 15 is 10. 10 minus another 10 is 0. And 5 works. It makes my equation true. That means it's a solution of my equation. Negative 2, let's check and see if it also makes the equation true. If I plug in negative 2 and I square it, negative 2 times negative 2 is 4. If I plug in a negative 2 here, I get a negative 2 times a negative 3, which is 6. So far, I've got 4 plus 6 is 10. Take away 10 is 0 again. And I have 2 solutions, which is exactly how many solutions I should have had because I have an x squared or quadratic equation. Isn't that cool? Okay, so how do we find those solutions? Now, we just were given the solutions and we checked and plugged them in for the x's and they worked. But how do we find those solutions by ourselves? So the zero factor theorem or the zero factor property, if p and q are any real numbers and if p times q is 0, then either p times q, p is equal to q, or p is equal to 0, or q is equal to 0, or they're both equal to 0. Okay, so that is our zero factor property. Now you can play with this and it makes sense. Okay, so basically, if I know that 5 times something is 0, so 2 numbers multiplied together is 0, what's going to make that true? If I divide both sides by 5, then I get something is 0 divided by 5, which is 0. So doesn't this unknown number have to be 0? So play with it. See if you can make a product that's equal to 0 without using a 0 as a factor. You can't do it. Okay, so that's what this factor theorem, zero factor theorem, is telling us. It's saying that if we have a 0 product, one of our factors must be 0. And in order to find every possible factor, we set all factors equal to 0 and we solve. Now, one thing I want to clarify. I said that quadratic equations have 2 solutions and cubic equations have 3 solutions, and that is true. However, you're not going to be able to see all those solutions right now in Algebra 1, because Algebra 1, we speak of a limited system of numbers, which is the real number system. Just wait until you get to Algebra 2, and you open a whole new world with what's called imaginary numbers. So, even though quadratics have two solutions. Sometimes you might have solutions that are not real. And we're not talking about those in Algebra 1. However, solutions that are imaginary are just as fun as they sound. And there are a lot of things that we can't do without imaginary numbers. And when you get to Algebra 2, we'll talk about that again. But imaginary numbers are used in the circuit equations for your electric lights. And imaginary numbers are used in heat equations and anything that has to do with energy equations are all going to involve imaginary numbers. So that's pretty cool. And you'll learn a lot more about that later. So what I said is true, but there are going to be a lot of equations now that won't have two solutions if they are quadratics. Okay, so because you do not know anything about imaginary numbers yet, but you will. And you'll be able to do those in Algebra 2. Okay, so how are we going to use this zero factor property to help us solve quadratic equations? Well, we're going to do factoring. Now, this is a quadratic equation that has already been factored for you. We're going to have to learn how to do this. But now that it's been factored for you, the quadratic equation is in the form of a factor times a factor, or a binomial times another binomial. And remember how we get this multiplied together is we FOIL it, and if we FOILed this together, we would find the polynomial that we started talking about. But we just jumped straight to the factoring. And now, if I use my zero factor property, since this product equals 0, that means by the zero factor property that either this one is 0 or this one is 0, or they're both 0. In order to find every possible solution to the equation, we set them both equal to 0. So x minus 3 equals 0, and x plus 5 equals 0. Okay, so x minus 3 means that x equals 3 when I add 3 and add 3. And here I'll subtract 5 and subtract 5, and I'll get x is negative 5. Two solutions. Now, what was that polynomial before we factored it? Well, let's FOIL it together. First, outside, inside, last. Remember your FOIL. First is x squared. Outside is 5x. Inside is negative 3x. And last is negative 15 equals 0. Now, if we do it right, then we get our little FOIL man. And I don't have room to put his little antennas up there, but he's our little FOIL man from Mars named Hermie. Okay, so when we FOIL this together, we put these two like terms together. We get x squared plus 2x minus 15 equals 0. So that is the equation that comes from multiplying these two factors together. So this equation should have this as a solution and that as a solution. Let's try it. If we plug in x is 3 for every x, do we get a true statement? Let's see. 3 squared is 9. Plus 2 times 3 is 6. Minus 15. So what is 9 plus 6? 15 minus 15 is 0, isn't it? So, yes, 3 is a solution of this equation, which is the same equation as that equation factored. So now let's try the other one, negative 5. Negative 5 squared is 25. Negative 5 times 2 is negative 10. 25 minus 10 is 15. Take away another 15 is 0. And negative 5 also makes this equation a true equation. Okay, so here we have an equation for example 1, and it's in the wrong order. So let's put it in standard form first. So I want my x over here, and when I move from one side to the other, it's going to change the sign, isn't it? So we're going to have x squared minus 3x, because it was positive over here. And basically that's just what? Subtracting 3x and subtracting 3x from both sides. And then I bring down the minus 18 equals 0. Okay, now remember that factoring is nothing but unfoiling. It's the reverse of foiling. So I'm going to put my little 2 factoring parentheses, and we're going to split up the x into an x and an x, because that x squared is the first 2 multiplied together. And then the outside and the inside add together to give me the middle term. And then the last term, negative 18, is the last times the last. So then remember, I start thinking of all the factors of 18. So let's factor 18. 18, 1, 2, 9, 3, 6. Those are all the factors of 18. Now remember, my equations are talking to me. I have a negative there, and a negative means difference. That means this 3x is a difference of 2 numbers. So 6 minus 3 is 3x. And that's the only one that's going to give me, only pair that's going to give me a difference of 3x. So I'm going to use 6 and 3 as my factors. I'm going to put the 6 in one of the slots and the 3 in the other one of the slots. And I want it to be negative, so I'm going to make the 6 negative and the 3 positive. So now we've got our little equation, x minus 6 times x plus 3 equals 0. Okay, so now that I have that, I'm going to set each factor equal to 0. So x minus 6 equals 0. And x plus 3 equals 0. And then I'm going to solve each one of these. So if x minus 6 is equal to 0, I add 6 and add 6, and I get x equals 6. If x plus 3 equals 0, I subtract 3 from both sides, and I get x is negative 3. So here are my solutions. But don't believe me. Go back and check. All right? So let's plug in back into the original equation. Let's plug in x is 6. We go back up here. 36, 6 squared is 36, minus 18. Well, 36 take away 18 is 3 times 6 is 18. Is 36 minus 18 equal to 18? Well, it is, because 18 plus 18 is 36. So 36 minus 18 is 18. So this one is made true by x equals 6. Let's try x is negative 3. See if it works. So we go back up here. Negative 3 times negative 3 is 9. Minus 18 is negative 9. And we're plugging in what? We're plugging in a negative 3. Negative 3 times 3 is negative 9. So we had 9 minus 18 is a negative 9 on this side. And this side is also a negative 9. And a negative 9 equals a negative 9. And therefore, x is negative 3 is also a solution to the equation. If it makes the equation true, it is called a solution of the equation. How many solutions did we have? 2. What was our equation? It was quadratic, which means it started with an x to the 2. So we had at most 2 solutions that we can find in this course, and we found them both, and we can be guaranteed that that's all there is, because a quadratic can only have 2 solutions. Isn't that awesome? Here we go. Negative 25 equals negative 4x squared. Okay, so it's kind of in a weird position. It's certainly not in standard form, is it? So let's put it in standard form. Let's add 4x squared to both sides. So if I add a 4x squared and I add a 4x squared on this side, then I'm going to get 4x squared minus 25 equals 0. That's in standard form, isn't it? So whenever we have a difference of two squares, it factors into conjugates. And conjugates mean I take the square root of this one, which is 2x. I take the square root of this one, which is 5. And I put a plus. And then on the other side, I put the same numbers, but I put a minus. Those are conjugates. They are the same terms, but opposite signs. Now, if I FOIL these together, guess what happens? I get 4x squared. My outside is negative 10x, but my inside is positive 10x, and they cancel. And then my last is negative 25, and I get a minus 25. So these two FOILed together gives me the equation I'm trying to get. Therefore, these are my factors. And I'm going to set each one of them equal to 0 by the zero factor property. So if I set 2x plus 5 equal to 0, I get minus 5 minus 5. 2x equals negative 5, or divide by 2, divide by 2. X is negative 5 halves. Well, guess what happens when I get this one? I'm going to get the same terms, but the opposite sign. So x is going to be positive 5 over 2. Okay, so if I put in a positive 5 over 2, then don't I get a 0 right there? I do. So I have two solutions. Now if I go back up to my original equation and I plug both of those in, guess what? It does make the equation that with the original equation will now be true. So basically, they're checking each one of these for you in your book. So I'm not going to check every single one of them for you because they're doing it for you in your textbook. All right, so now here we have our next equation. This is example 3, but we don't have it in standard form. So we need to get our x squared on the left. So we're going to add an x squared. We're going to add an x squared all the way over here because none of these terms are like terms. We're going to get x squared plus x minus 56 equals 0. Okay, so now we're going to factor this side. Well, I know that this one right here has to be made up with an x times an x. So I'm going to put x, x. I know that this one comes from this one times this one. The two last terms put together have to multiply to give me a 56. I also know that this minus sign is talking to me because it's telling me, okay, I'm going to take these factors and the difference is going to give me 1x. So I am going to factor 56. Well, I can start 56 and 1, 2, 28, 4, 14. Now I'm looking for a difference of 1. None of these have given me a difference of 1. But what happens when I cut this one in half? I mean, double this one, I get an 8. And I cut this one in half, I get a 7. Isn't 7 times 8 56? And isn't the difference between 7 and 8 1? So we want 7 and 8, don't we? These are the factors that have a difference of 1. So I'm going to come up here and put 7 and 8. Now, one of them is going to be minus because this tells me I have to have opposite signs. So I want this to be positive. Therefore, I'm going to make the big one positive and the smaller one negative. And I have factored my equation. So now I'm going to set each factor. Now, that's just an underline. It's not a z. It's a 7. So x minus 7 equals 0. Well, if x minus 7 equals 0, then add 7, I get x equals 7. If x plus 8 is equal to 0, then isn't x equal to negative 8? All right, so this one's pretty simple. Let's check it. Let's plug in a 7 right up here. 7 take away 56 is equal to negative x squared. Well, we're talking about 7 here, so negative 49. Is 7 minus 56 equal to negative 49? It is. Could we think of this as 56 minus 7 and then just change the sign? It's 49 and it's negative. Okay, so 7 makes it true. And negative 8 also makes it true. Let's do it. Negative 8 minus 56 is the opposite of negative 8 squared. Well, negative 8 squared would be negative 64. So we're going to have negative 8 minus 56. Add those two together, I get minus 64. Okay, so here is our last example before we work on our practice problems. 3x squared minus 6x equals 9. It's not in standard form. So let's subtract a 9 from both sides. We'll subtract it from this side. So 3x squared minus 6x equals, minus 9 equals 0. So now it's in standard form, which means I can factor it. So I'm going to factor it, but now instead of being x times x, because x times x does not give us 3x squared, we're going to make it 3x times 1x. And 9 could be factored 9 times 1 or 3 times 3. And this means that I'm going to have opposite signs. So that means that this is going to be a subtraction. Now, since this is going to be a result of a subtraction, I'm going to first try to put in a, let's see, 9 and a 1. Let's see if that's going to do for us. So now, 9x minus 3 is a 6x. That looks like it might work. Okay, so let's FOIL it. We have a 3x squared. We have a 9x minus a 3, but I need this one to be negative because I need a negative in the middle. And then I have my negative 9 on the end. So there are my factors. So I'm going to set each factor equal to 0. So 3x minus 9 equals 0, and x plus 1 equals 0. So if I add 9 to both sides, I get 3x equals 9, which means x equals 3. And if I subtract 1 from both sides, I get x is negative 1. Now that I look at it, I see, you know what? I could have made that easier. I got it right, but I could have made it easier. Because notice that this equation could have been divided all the way across by 3. Let's do that first because it makes it easier to factor. So what we have is right, but we're going to make it easier. So we're going to divide everything by 3 because 3 goes into each one of the terms. So divide by 3, divide by 3, divide by 3, and divide by 3, all the way across the equation. So 3 divided by 3 is 1, so I get x squared, minus 6 divided by 3 is 2x, minus 3 equals 0, because 0 divided by 3 is still 0. Now I don't have a 3x squared. I just have an x squared. I should have done that to start with. But guess what? I'm still going to get the same factors because now I have x, and then I'm going to have a 3. So that's going to be a 3 and a 1. I want a negative 2 in the middle, so I'm going to make it a negative 3 and a positive 1. And there are my factors. But now x minus 3 is the factor. So if I add 3, if I set it equal to 0, add 3, I get x is 3, which I already had. I had done it right. I had just done it the long way. And then x plus 1 means that x is negative 1, and here's my answer. Okay, so now when I plug it back up there, let's plug in 3 and negative 1 were our two answers. And let's check. If we plug in a 3, we're going to get a 9 times a 3 is a 27. Take away a 6 times a 3, which is 18, It does leave me 9, doesn't it? That was our previous work. So this one is a check. And then we plug in a -1. -1 times -1 is 1. Times 3 is 3. And 3, -1 times a -6 is +6. So 3 plus 6 is 9. Now we're ready to do our practice problems. Here we go. You have 2 practice problems. This one is your first one. So you want to write it down and do your best. But remember to put it in standard form first. Okay, hopefully you did that. So we're going to put this in standard form. We're going to add a 5x to both sides. We want to get rid of this one too, so we'll subtract a 24 from both sides. When we do this, all of this goes away, and I have a 0 on the right. On the left, I have an x squared plus a 5x minus a 24. And I have everything on the left, which makes it very easy to factor. So remember, to use our zero factor property, we have to have a 0 on one side. So that first step is very important. So now we're going to factor x and x. We're going to think all the ways that we can factor 24. 24 and 1, 2, and 12, 3, and 8, 4, and 6. Those are all the ways that we can factor 24. The minus sign tells me that we have opposite signs, and that's going to be a difference. So I'm looking for factors that have a difference of 5. 8 and 3 have a difference of 5. So let's plug in an 8 and a 3. We want this middle term positive, so we make our big one positive, make the other one negative, and when we FOIL this together, don't we get our equation? Set it equal to 0, use our zero factor property, x plus 8 equals 0, x minus 3 equals 0. Our solutions, when I subtract 8 from both sides, I get x is a -8. And when I add 3 to both sides, I get x is equal to 3. Okay, so when I plug these back into my original, which has gotten kind of messed up here, let's go back and put it in its original form so that we can check it. Okay, so it was x squared minus is equal to minus 5x plus 24. Okay, so let's check it by plugging in first a -8 and see if we get a true equation. -8 times -8 is 64. -5 times -8 is 40 plus 24. Well, that's certainly true, isn't it? Okay, so this one is true. So now let's go plug in a 3, positive 3. It's an equal sign. So we're going to plug in a positive 3. So I plug in a positive 3 here, I get 9, because it's 3 squared. Minus 5 times a positive 3 is minus 15, plus 24. Is 24 take away 15 equal to 9? Certainly is. So that is your first practice problem. We have one more, and we are done with this lesson. Last practice problem. And we're through, and you get to do your homework. So go ahead and copy it down. Put it in standard form. Make sure you have a 0 on the right-hand side. Factor the left-hand side. Set each factor equal to 0. And then check to see if your answer works. Okay, so here we go. I need to get this in standard form, which means this needs to go on the other side. So I'm going to add an 8x. I'm going to add an 8x over here. That's going to go to 0. So we're going to put these in the right order now. So x squared goes first, positive 8x goes second, negative 48 goes third, equals 0. Okay, so now we're going to factor this left-hand side. Well, I know the first part is a 1x squared, so it's going to be x. 48 is going to be these two multiplied together, and it's negative. That means this is a difference. So let's think about factors of 48. 48 and 1. Well, that doesn't have a difference of 8. So 2 and 24. That does not have a difference of 8. 3 and, what is it? 3 and 16. 3 and 16. And that doesn't have a difference of 8. So 4 and 12. That one does have a difference of 8. 12 minus 4 is 8. So I'm going to put 12, 4. I want the middle term to be positive, so I'm going to make my big one positive, my other one negative. I'm going to FOIL it together to check it. X squared, 12x minus 4x is 8x. And I do get a negative 48 when I multiply 12 times negative 4. So I know my factors are correct. So now I'm going to set this factor equal to 0. And I'm going to subtract 12 from both sides and get x as negative 12 for one of my solutions. I'm going to set this factor equal to 0. X minus 4 equals 0. I add 4 to both sides. X equals 4. But don't believe me. You need to go check it, don't you? Okay, so we're going to go back up here to the top and go back to our original equation. That was a negative 8x. And we're going to try a negative 12 first. So negative 48. And negative 12 times negative 12 is positive 144. And negative 8 times a negative 12 is a positive 96. And 144 minus 48, is that equal to 96? Well, I know that 14 take away 8 is 6, and 13 take away 4 is 9, and that works. So we have checked this one. This one works. What about 4? Does 4 also work? So we'll erase that since we already checked that one. We're going to plug in a positive 4. So negative 48 plus 4 squared is 16 equals negative 8 times 4 is negative 32. So we look at that and we say, is that true? Is negative 48 plus 16 equal to negative 32? Well, it is, because if I add these two together and I have both negative signs, then I get a negative 48. That is correct. Therefore, we have found and checked our solutions because they make our equation true. So we have learned that we can find the two solutions to a quadratic equation by factoring. Doesn't always work, but in the assignments that you're doing in your homework, it will work because they're going to only give you ones that it works on. And we've learned a lot. This is Mrs. A, and may God bless your day.